So I will continue about the AI foundation. So what is the AI foundation? On Monday, we learned about the AI journey. So at the time, we learned about the Turing machine, Turing tests, and the birth of AI. You learn about what is AI summer, AI winter, and the modern technology of AI. So we are going to learn about the foundation of AI. What are the diverse fields that give impact to AI, and also about the intelligent agents. So there are various types of agents in AI. So we are going to learn some of them. So this is what we are going to learn. There are different aspects of knowledge as the foundation of AI, and there are some property of task environment. So we are going to learn about PEAS, PEAS, and then some of the word for defining the tasks in AI. So there are many fields that impact the AI. I will not discuss one by one, but we can see the philosophy. I think it is the most important part for the AI because it is based on the logic. So AI, you need to understand the logic, and then how to do the reasoning. And there is also a foundation of learning in the philosophy. Of course, you need to learn about the mathematics. Okay? So in our department, you join in the Suhak mathematics. That is also the foundation of AI. There are some formal presentation. So you need to understand how to prove the mathematics. And you will learn about algorithms. You will learn about the computation. And you also need to understand about the economics. So in our department, you will also learn. I forget what is the name. There is one course about economics. So you learn about the utility, division theory, and rational of economic agents and structure. When you come to the data mining, later you will learn about the neuroscience. How the neurons as information processing units. So if you know what deep learning, and if later on, maybe you also learn a little bit about neural network. So those things are from the neuroscience. Psychology. So psychology refers to how do people behave. Because AI trying to imitate the human behavior. AI try to make the human life easier. So we need to understand how do the people behave. How do the people perceive? How do the people process the information? How do the people represent knowledge? So there should be some experimental techniques. So that's why the psychology also affect the AI. And of course, this is the most important thing in AI, computer engineering. So if you understand the computer engineering, you can build the AI with the fast computers. There are some additional things that you need to understand how to do with AI. For example, if you understand the control theory of the cybernetics, it means we can design some system to maximize the function of time. It is not that important, but if you can understand it, of course, it helps the API. Linguistics. Linguistics means you can understand some grammar because now with the ChatGPT, DeepSeek, and all those things in the linguistic, you need to understand the knowledge representation. And you will also learn about statistics. Okay. So in this case, it is also one of the necessity knowledge as the foundation of AI. So you can see there are a lot of knowledge that impact to the AI. There is one word PEAS, which defines the structure of an intelligent agent in AI. So PEAS stands for performance measurement, which is P. Environment is E. Actuators A. And sensors S. Okay. So we call it the PEAS. Performance measurement. What is it? So the performance measurement defines the criteria for evaluating the success of an agent. It depends on the task. For example, if you do recommendation system, then you will need the performance measurement for measuring the accuracy. If you are building a robot, then you need to measure the energy efficiency and so on. So every AI will have their own performance measurement. The second word, which is E, is environment. So environment means the external surroundings in which the agent operates. So for example, a self-driving car's environment are roads, traffic, and weather conditions. So we need to know what are the environment. A refers to actuators. So actuators means the mechanism that the agent uses to take action and interact with the environment. So for example, a robotic arm in manufacturing. So in the factory, if you want to perform a robot, then the robot should have hand, like a human. So if the robot have hand, then how can we make the hand equal to human? So that's the actuators. The other thing in the AI, for example, if you use the ChatGPT, it is a kind of chatbot. So the actuators means when I click the button, then what is the response from the chatbot? And S refers to sensors. So sensors are devices or software components that collect data from the environment for decision making. So we need to get some data from the environment. Let's say if it is a self-driving car, then we need to have camera. If it is a voice assistant, then we need to have a microphone. Okay, so the PEAS is one of the important factors to make the intelligent agent. When you do the final project, you need to define your PEAS. Now, let's see some examples. Okay. Let's say I want to make an agent. So the agent is for medical diagnosis system. Medical diagnosis system is for the hospital. Okay. So can you figure out what is the performance measure? What is the environment? What is the actuators? And what are the sensors? Okay, I give you one example. So when I want to create a medical diagnosis system, so I need to define the performance of the sensor. The performance of the sensor, I need to check the healthy patient. So the standard is if the patient is sick, if the patient has some illness, then I need to cure the illness so it will become a healthy patient. So the standard is how to cure the patient as a healthy patient. The second measurement, we know that the hospital cost is very high. So how can we minimize the cost? The other kind of performance is the losses. Losses means if we want to cure the patient, how we can make sure that there is no confusion, there is no criminal. The patient will be cured without any problems. So this medical diagnosis system should have this performance measure. What are the environment? So the environment means the patient itself, and then the hospital. So it means the hospital should have some facilities. The hospital should have some good environment. The hospital should have good machine, and also staff. What about the actuators? Some of the actuators are the screen display. So, for example, if you go to hospital, then you can meet the doctors. Now, if I want to make the agent, then you will not meet the doctors. You will meet the screen. And when you meet the screen will give you questions. The screen will give you tests. The screen will give you diagnosis. The screen will give you treatment. The screen will give you referrals. And what are the sensors? So the sensors in this case, we can see the keyboard. So the keyboard, it means I would like to type something. Enter the symptoms. And he will type. Or he will do some finding. So now there are many sensors. By using some fingerprint sensors, they can know about your heartbeat. With many sensors, they can know about your condition and so on. And maybe we can get some patient answers. So this is the PEAS for the medical diagnosis system. Now let's see another example. I want to make an automatic taxi. So the agent is a taxi driver. So what is the PEAS for the intelligent agent for taxi? Okay, let me give you the answer. So for a taxi driver, we have the performance measure. First, safety. So when you want to make an intelligent taxi driver, safety is the first. And people use taxi because they want to get to the destination faster. And it's the best. The other thing is legal. So is it a legal taxi or not? If it is illegal taxi, then don't provide that service. And whether the taxi has the comfortable trip. This is also important as an intelligent taxi. And how the taxi driver can get the maximum profit. So those are some component lessons as a taxi driver with the intelligent agent. Now, the environment, I think this environment will be similar with the automated vehicle. We need to check the road. We need to check the traffic. We need to check the pedestrians. And we need to check the customers. If the customers are male or female or children or baby. So every different customers, they will have different kind of service. Actuators. So we know a taxi means a vehicle, car. So the actuators can be the steering wheel, accelerator, or the brake, the signal, the horn, and the throttle. And the sensors, they are cameras, solar, speedometer, GPS, odometer, engine sensors, keyboard, and so if we can define this one, then we can make the intelligent agent as a taxi driver. Now let's see another example. Part picking robot. You know. So in the factory, there is a robot to select some component of the product. So we need to define the component method, environment, actuators, and sensors. So if we want to specify the intelligent agent as a part picking robot, then we need to have the following method. The percentage of parts in the cockpit. And the environment are the conveyor belt with parts and pinning. The actuators, it means the robot. It will be the jointed arm and head. The sensors are the camera and the joint angle sensors. So every kind of intelligent agent, there will be the P, E, A, and S. The other kind of intelligent agent, for example, I want to create an interactive English tutor. And we can define also the PEAS such as this one. The agent is an interactive English tutor. The performance method is to maximize the student score on a test. And the environment is a set of students. The actuators are the screen display. So you can show some exercises, you can show some suggestions, and you also show the corrections. What about the sensors? Sensors are the keyboard. Okay. So using these examples, now let's try to figure out Or maybe I will put the questions at the end. Now you can understand the PEAS for every kind of intelligent agent. We can understand this intelligent agent in different kind of task environments. Now I would like to explain about some other definition. The first definition is the observable. Observable means whether I can observe some things or not. We call it fully observable if the agent has complete information about it at all times. Otherwise, it is partially observable. For example, do you know chess? Okay, I think most of you know this game, chess. We call this is fully observable. Why? Because the player can see the entire chessboard and all pieces. So if you are the white, you can see the position of the black. So you can figure out what is the possible movement for your opponent. Then you can see the black, you can see the white, all the things at the same time. Because this is fully observable. Do you know poker? If you like to play card, so there's one game we call it poker. So when you play the card, yeah, maybe this is poker or blackjack or any poker, any card game. So the players cannot see the opponent's card. So I can see my own card, but I cannot see his card. I cannot see his card. So only their own and community cards. So only the person only can see their own card and the community card. It means because this is partially observable. So I cannot see all the things. I can see only partial. The other things about the task environment, we call it deterministic. Deterministic if the next state of the environment is completely determined by the current state and the agent's action. Otherwise, it is stochastic. Okay, so they are only deterministic or stochastic. So, do you know tic-tac-toe? This is a game. So, we have 3 multiplied by 3. So, if I put the O here, so what is the possible x? X can be anywhere, but not in this position. So, because this is deterministic. Let's say I put x here. Then, I can put O anywhere, but not here and not here. Maybe I put here. Then X can be anywhere, but not here, and not here. So let's say I put here. So O can be anywhere, but not in this place, not in this place, not in this place, not in this place. Then let's say I put here. X can be anywhere, not on those positions. So let's say I put here. Then now X will. So this is what we call as the deterministic. The result of each move is fixed and predictable. So you can predict easily because the locations are very determined. Stochastic is something, the outcome depends on the chance and is not fully predictable. For example, when you roll a dice, then the probability of getting 12 is, it is very small chance. You cannot figure out whether you will get 12 many times. 12 means you need to have the dice 6 and 6. So it is very rare. Then it is stochastic. Episodic. The episodic environment means the agent actions are divided into independent episodes with no effect on the future decision. We call it the image classification as an episodic. So image is classified independently and past classification do not affect the future ones. So if you learn later about this image classification, let's suppose I input an image of cat and I input the image of dog. So if you later on understand the image classification, then we can classify, okay, this image is cat, this image is dog, is on the training result. So this is an episodic because it does not affect what you learned in the past, but as I know this figure is an cat, then I will classify it is as a cat. I know this is a dog, so when I put into the model, then this is a dog. There is another kind of episodic, we call it sequential, not episodic. It means each move depends on the previous moves and it affects the future state. So if you play the chess, when you put some of this one, if you move this one, then your opponent will think what is the best move. So it affects the future state. So we call this sequential, not episodic. We need to check also the environments, whether it is a static or not. Static means the environment does not change while the agent is deciding on an action. So, for example, if it changes independently, it's dynamic. Let's say a crossword puzzle is static, but self-driving car is dynamic. So this is crossword puzzle. Have you ever played this one? Carousel. Okay. So what is the word in this blank? So there will be questions, and then you need to fill the blank. So this kind of crossword puzzle is static because you already know the environment. The placement is always on this part. The placement of the text always in this part. The environment is static. But if you are doing the self-driving car, it is dynamic. It depends on the road traffic. It depends on the how many cars in the road. It depends on the size of the road. It depends on the city and etc. Discrete. An environment is discrete if it has a limited number of states, actions, and percent. Otherwise, it is continuous. Chess is, well, I think I mentioned a lot of things about chess. So chess the game has a finite set of moves and position. So you can play the chess just with the 8 multiplied by 8 move. So 8 for the horizontal and 8 for vertical. It is just limited with this one. But what about the robot? I think you know the robot police. If the robot police move, then it is very dynamic and it is continuous. The direction, the speed, and the action is in a continuous space. So the environment is very continuous. And we need to check the agent, the number of agents. A single agent means a system where only one agent interacts with the environment. If there are multiple agents, then it becomes multi-agent. Have you played solitaire? So solitaire is a game in the computer. Okay, so you can check in Windows, you can play a solitaire. And when you play this one, you can play this game alone. So you don't need to have friends. You can finish this game by yourself. So we call this is just a single agent. So the player interacts with the environment alone. But what about soccer? If you want to create a robot soccer, then you cannot play the soccer alone. So you need to play at least with 2 players. So it is the multi-players, or we call it multi-agent. We call it multi-agent. So based on those such environment, we can figure out what kind of agent we want to create. If the first one, it is about the medical diagnosis system. So we have the process, actions, goals, and environments. So the environments are patient and the hospital, and goals or the performance measurement. We want to make sure the patients are healthy, and we want to minimize the cost. And the actions, we can give questions, we can give some tests, and we can give treatments. And then the process. So we need to understand the symptoms, we need to understand the findings, and based on the patient answers. So the percepts means what we can get from the sensors. The satellite image analysis system. So the environment is the images from the satellite. The goals, we want to make the correct categorization. The actions, we want to print a categorization of scene. And the percept or the sensors, we have pixels of varying intensity or color. Part picking robot. So we have the conveyor belt. And we want to place the parts in the correct bins. So the actions are pick up parts and sort into bins. And the percept or the sensors are the pixel of varying intensity. It is also the definition for the refinery controller, and this is the definition for the interactive English. So you can see different agent is different environment, performance measure or the goals, actuators or actions, and different sensors or processes. Okay. So at the end of this class, as I mentioned to you, you need to make a final project. So your final project is to design an intelligent agent. So you can have some imaginary means something. Okay? So you can make some new idea. What is the agent type? And then you can define the environment, the goals, the actions, and the process. And we can also define this one word on the task environment that we learned previously, whether it is observable or hidden. So this is a game, solitaire. This is another game, backgammon, similar to chess. This is internet shopping. This is taxi. So solitaire, is it observable? Yes. So we can observe every part. Backgammon, similar to chess. Yeah, it is also observable. What about internet shopping? It is not observable because we cannot see all the products at the same time. What about taxi? This is not observable because we cannot understand all the rules at the same time. Deterministic. So you already learned deterministic and the stochastic. Solitaire is, yes, deterministic. Backgammon, okay, it is stochastic. The movement is very random. Yeah, maybe I don't show it the backgammon here. Internet shopping. So partial deterministic, partial stochastic. And taxi, it is totally not deterministic. Solitaire is not episodic. Backgammon is non-episodic. Internet shopping is non-episodic. And taxi is non-episodic. What about the static? Solitaire is static. Yes, because we can see all the parts and it is just about the card 13 card multiplied by 4. So we have only 52 cards. Backgammon, it is semi-steady. Internet shopping, it is semi-steady. For taxi, it is non-steady dynamic. Whether it is discrete or continuous. Solitaire is discrete, backgammon is discrete, internet shopping is discrete, but taxi is continuous. And solitaire is single agent. All those things are not single agent, multi-agent. So you can also define your final project based on this task environments. And this is another example. Okay? So this is just for your reference. There are many other agents. Crossword puzzle, chess with clock, poker, backgammon, taxi driving, medical diagnosis, image analysis, part picking robot, refinery controller, interactive English tutor. So you can define whether it is observable, deterministic or static, stochastic, episodic or sequential, static or dynamic, discrete or continuous, and what the agent, whether it is single or multi-agent. Now let's do this one together. Let's see, we have a smart vacuum cleaner. I think some of you may have this kind of robot. This is the LG iRobot vacuum cleaner that can clean the house automatically. Now let's identify what is the P, what is the E, what is the A, and what is the S.